5.5. This is the last concept for the chapter. It's going to take us a couple days to get through it. It's called standard deviation. And my overall view of this, see if I can grab my red pen here, is that this is a way to measure shape and spread using just one number. Now it's a little complex to figure out, so bear with me, but it gives us something to hinge a lot of information on. All right, let me start off by looking at these two sets of numbers here, and if we look at them in some sort of detail, we can see they're different. They're not quite the same. They do both have the numbers 1, 5, and 9. Now, if we start to analyze them with our normal numbers, such as, let's find the mean, say, of the first group. I should have labeled it here. We'll call this one Group A and Group B. So Group A has a mean of 5, because they add up to 25, and there's 5 of them, so if you divide 25 by 5, you get 5. The range is 8. Yeah? Let's look at Group B. Again, adding those up, 9 plus 1 is 10, 6 plus 4 is 10, so again we have 25. And again, there's 5 items. So our mu, again the average, the mean, is 5. The range, 9 minus 1, still 8, and neither of them has a mode. So there's nothing to really look at there. And finally, if we look at the median in both cases, what is the middle number? It doesn't take long to see that with 1 and 9 being the high, that the other 3 numbers are all in the middle, and 5 is in the middle of those 2 numbers. So 5 is the median in both. So even though we can see the sets are different, the statistics on them are the same. And so this kind of shows us that we do need something else, some other way of measuring these. If you look at Group B, for example, Group B has 3 numbers that are all close to the middle, and then 2 further out. This should tell you that it's a very normal looking graph. Again, imagine that there were not 5, but 500 items in this list, yeah? And they were all in those same regions of them. Whereas if we look at set A, clearly here we have a different shape. There's nothing actually empty. Instead, we have 1 and 2 being on the lower end, 9 and 8 being on the upper end. So we actually have something of an inverted, an upside down hump, where most of the data is on the end and there's nothing in the middle. So our standard deviation is going to show us that those sets are different. All right. All right, here is what you should have written down about the standard deviation. It measures how far data items are from the center. And let me take you to a picture of the normal distribution. So this is called the bell curve, but most people think of it as just a normal looking distribution curve with most of the items centered around the middle. And then remember, we talked about those 2 tails. So there's a tail here and then a tail here. So what our standard deviation, and by the way, this is sigma. It's the symbol that we use for standard deviation. It looks like a cherry, an olive, whatever you want to call it. But it measures, if we break those regions up into equally spaced distances, yes? Think about each of these dotted lines as being the same distance left to right. Then those are areas or regions, okay? And each one of those would represent a standard deviation. So here in the middle, we have the center, we've got the mean, and then if, for example, you were looking at a data item that was, maybe on the left side here, right? That would be 2 or maybe 1.5 standard deviations away. If it was way out here, it would be 4 standard deviations away from the mean. So it tells us how close we are, all right? And the standard deviation, the number itself, tells you that distance right there, okay? So what is that horizontal distance for each of the standard deviations? Here's the formula, and we're going to use this for standard deviation. It's pretty complex. I break it into 6 steps. First of all, notice a couple things about this. There is a square root at the very end, so you'll need a calculator. We've got to sum up or add up a bunch of things. In fact, we're going to add up a bunch of what we call squares. And we've got to do a subtraction, we've got to find the mean, and then we also need to do some dividing here. All right? So I'm going to go back to the original 2 items. Let me, first of all, actually take you down the steps. I've written this handy little acronym, ADS. So ADS twice, so 6 steps. The first thing we're going to look for is the average. Let me get, here we go. So average. So what is X bar in the case? We need to find that first of all. Then we need to find what's called the differences, which means we need to do some subtracting. Then we need to square each item. Then we need to add those items up. Last 2 steps, we are going to divide. Specifically, we need to write down divide by n minus 1, n being the number of items. Okay? And finally, we need to take that square root. All right, a little Willie Nelson there in the background, I don't know if you can hear it. So here is my data set. All right, we found the average already. We did that at the beginning of the lesson. So now I'm going to go through and I'm going to subtract. And I'm going to put that in my list of differences. So 5 minus 1 is 4. I'm always going to take, by the way, the absolute value of the difference. So 5 minus 1 is 4. 5 minus 2 is 3. Again, I'm subtracting. 5 minus 5, I get 0. 5 minus 8 is 3. 5 minus 9 is 4. Okay, and we're going to square each one of those items. So I get 16. That's 4 times 4. 3 times 3 is 9. 0. And 9 and 16. Now we got to add those numbers up. 16 plus 9 plus 0 plus 9 plus 16. Well, 16 and 9 is 25. And then 25 plus another 25. So the sum is going to be 50. And then we need to divide by n minus 1. In this case, n, how many items are in my list? It's 5. So I'm going to divide 50 by 4. All right? And that's going to give me 12.5. So we're going to take our calculators and figure out what is the square root of 12.5. Again, hopefully you've got a calculator near you. And see if I can. There we go, 12.5. Enter. So I get 3.54. If I round it to the nearest hundredth, yeah, it says 3.535555, right? Well, I round it up then to 3.54. So let's now go and look at this other data set Again, this tells me the distance, right? That horizontal distance. Let's go look at this one. Here the standard deviation should be shorter because more of the items are closer to the middle. All right. So again, the first thing we're going to do is find the average, and we did that. Okay. Then we find the sum of, the differences. Whoops. Got to difference them first of all. So again, subtracting each one of these items from the mean. So 5 minus 1 is 4. 1, 0, 1, and 9 minus 5 is 4. Again, just take the positives. And yeah, look at that. Wow. Our garden is still producing food. All right, now I square. Okay. So how did I write that up? No, square. Square. 16. 1 times 1 is 1. And 16. And then we need to find the sum of those items. So sigma. So 16 and 16 is 32. And then I get 34. All right, we next need to take and divide that. So we need to divide by n minus 1. So in this case, 34 divided by 5 minus 1, which is 34 divided by 4. And my calculator says 8.5. And finally, we're going to take a square root of that. So what is the square root of 8.5? And again, we're not going to get a nice number. It's okay. We're just going to round off our answer. And we get 2.91. 2.92 actually. Again, we got to round that up. All right. So we compare our two numbers, 2.92 and 3.54, right? So this one, let's write this down. This is smaller. So the distance is smaller, right? And again, I'm going to draw that graph out. Here's the middle. So if I think about these little areas or regions of all my data spread out, and again, we're not thinking about 5 items, but rather 500 items in the list. And these items in the second group will be closer to the middle because the distance is smaller. Yeah? If I look at those two distances. So each of these distances is closer. So they're packed together tighter, if that makes sense. All right. Good luck on your homework exercises in calculating standard deviation